Okay, so let's talk about diameter of binary tree. So you're given a root of a binary tree. Return the length of the diameter of the tree. The diameter of the binary tree is the length of the longest path between any two nodes in the tree. The path may or may not pass through a root. So in this case, 1, 2, 3, 4, 5, right? The diameter is 4, 2, 1, 3 or 5, 2, 1, 3. It depends how you visit. So in this case, you are actually just visit every single node and then count the depth, the depth of the tree, and then you just compare your children, and then you pick the biggest one, the maximum one, and then you update it. So I'm going to have a max variable that keep updating when I have a greater depth. So I'm going to say, so in this case you definitely need a helper function. So I'm going to say depth equal to 3 known, and I can say root. So in this case you cannot just finish in one function, so you need a helper function. And even though we are using int depth function, but we don't actually need to assign, and then we have to return max. This is how we actually need to return, right? So in this case, you can actually check if the root is equal to null, and I will just return 0. And I will have the left child of this root. So I'm going to call the helper function, and then root dot left. So you actually just keep visiting my tree, and for every single time, for example, I'm passing the node 1 to the helper function. So L and R is actually represent 2 and 3, right? So I will just update in my max equal to so don't forget, maybe the maximum is still the maximum, so you have to remain at the max, and then L plus R, right? So in this case, you need to have L plus R because it could be depends how you actually count the number of the depth. Then at the end, I just have to return what? The maximum between the left and right plus 1. There's a reason why you need to plus 1, because plus 1 is actually the root itself. So imagine 4 and 5. 4 and 5 are definitely 0, right? So the maximum are not going to change, but when you update in this child, I mean this node, right? It's level 1, right? The depth is 1, so you still need to add 1 at the end for the return case, even though the L and R are 0, right? They are definitely 0, so they just run the code to see if I have any error or not, and that will be pretty much. Okay, cool. So let's talk about time and space. So for this case, time complexity is all of n. You still need to visit every single one, be honest. And later on for the space, I would say all of h. H represents height of the root, height of the tree. So in this case, you only visit one node on the right side, but the left one you can only visit half of it because they are actually equal, right? So we know it's all of h for the space, and this will be the solution. And if you like the video, please press like and subscribe if you want it, and leave a comment below if you have any question, and I will see you next time. Bye.